Awesome. Thank you so much, Sarah. I really appreciate it. And good afternoon, everybody. I appreciate your time during this lunch and learn. I'm still getting used to doing things virtually, so I'm used to being in person and talking to everybody. So bear with me. So again, I'm Frank Hahnel. I'm with NavVis. I'm here to talk about SLAM technology. Specifically, my presentation is titled "From Control to Capture: Applying SLAM-Based Mobile Mapping in Modern Survey Workflows." I'll start off with a little slide about myself, just so everybody knows my background and where I come from. So I'm a native Floridian, born and raised here in Central Florida, specifically in Winter Park. So a little south of you all in Florida compared to Georgia. Although I did live in Georgia for a little period of time, I worked for a land surveying and civil engineering firm called PBS&J back in the 1990s, late 1990s. I also worked for a couple of different laser scanning manufacturers on the terrestrial side. One company called Leica Geosystems. I helped build out the 3D laser scanning market in the Southeast and then throughout the rest of the United States, as well as I ended up transitioning over to Trimble and helped them launch their X7 right around the late 2020s. I've done a wide variety of projects throughout my career, everything from responding to ground zero right after 9/11 to working with the Orlando Police Department to forensically map a crime scene after the Pulse nightclub shooting. Obviously, when you work in the survey industry for 30 plus years, you amass quite a few photographs, and these are just a couple of them throughout my career. Real quick, I assume everybody could see my screen. I probably should have asked that first.
Yep, I can see it.
All right, thanks. Thanks, Tyler. I appreciate that.
No problem.
So just a wide variety of different technologies that I've been involved in over the years. Some very well-known surveyors. You've got Charlie Brown, formerly with the North Carolina DOT, Joe Bruno, who created ESP and Associates out of the Carolinas. The lower right there is at the Fresh Kills landfill in Staten Island, New York, with one of the original Syra 3D laser scanners, the 2500. So a lot of technology. Like I said, I also responded to the Pulse nightclub. I received some accolades for working with the Orlando Police Department throughout my career. Quite proud of that. So what are we going to cover today? We'll get into the meat of it here. We're going to talk about why the conversation about SLAM is actually happening. What is SLAM? What isn't it? Where it works, where it doesn't work, the accuracy and using control while going and utilizing SLAM technology. We'll talk about a couple of real world applications. I've got many, but I don't want to bore everybody, and I know we have a short window here. And then also to discuss when to use it. So why is this conversation happening? Well, this isn't about new technology just for the sake of it. The conversation is happening because the work itself is changing. I think we all see it in our day-to-day lives. We're being asked to cover more area. We're being asked to cover and capture more detail and turn that information around faster without adding more people. As I travel throughout the Southeast, the number one complaint that I hear day in and day out is finding people, that wonderful thing, manpower. So on top of that, the expectation isn't just taking single shots anymore. It's actually creating a complete digital representation of the site, of the job site. I like to call it a digital twin. I'm sure you've heard that buzzword before. So the question becomes, how do we go about to meet those expectations without compromising our accuracy, our control, or our defensibility? And we always have to be thinking about that. And one thing real quick, I like to run my presentations. If you've got questions as I'm talking, I think there's a little hand icon you could throw up. Be more than happy to stop and answer. The idea is education here. I like the free flow. And I feel like if I try to wait until the end with questions, and we will have a question and answer session at the end, but if we wait until the end, you may forget your question or you may get called away. I know everybody's very busy. So where does the traditional workflow get stressed? Well, let me be clear. It's not about replacing total stations, and this isn't about replacing terrestrial scanners. Those tools are still the standard for a reason. Obviously, I worked in the 3D laser scanning for 20 plus years. These environments are, there are environments where this type of technology can start to get stressed. I've had situations where I've deployed with the scanner and, due to the line of sight, and that's what this graphic is trying to represent, just showing the actual line of sight that the scanners can see. It does cause some problems from time to time. And the nice thing about SLAM technology is you no longer are constrained to a tripod. You're actually able to walk around with the scanner. You almost, in a way, you become a tripod yourself, but you're not stationary, you're out walking around. So I can get into tight interiors. I can go into a mechanical room very easily. I've walked around industrial facilities. I've worked on job sites that were active, still had, construction workers walking around. I didn't have to shut it down like I've had to in the past using terrestrial scanning. I'm constantly moving. I'm constantly working around any kind of obstructions that are there. And the nice thing is I'm not missing anything. If I do everything right, when I get back to the office, I will have a complete and true digital representation of that job site, which is awesome. And in the past with other technologies, I've had situations where I've gone back to the office and I didn't have everything. So I would have to go back out into the field and, collect that missing data, that missing information. And one of the benefit with SLAM technology is it doesn't care. It's just going to scan everything as you're out there walking around. It's very efficient. It has great coverage, and we don't see any incomplete data. So SLAM without the marketing hype. I'm not a fan of any kind of marketing hype. I'm a fan of education. So at the core, SLAM is position estimation, as I like to say, over time, right? So as you're walking around with the technology, it's going out there and it's capturing that data, it's capturing that information, and it's on the screen showing you that data in real time. And in the lower right-hand corner here, I'm using my mouse here just to highlight, this is a representation of the feedback that you get while you're out there in the field. So you'll be able to see on the screen how good the data is, and if you have any type of issues with it while you're out there and collecting it. The idea is, you're going to go out there and you're going to walk in what we call loops. And that's the graphic that I've got in the upper right-hand corner here. So if this was the inside of a building that I was scanning, I would come in, I would walk into a room, depending on the size of the room or, warehouse, I may divide it up into a couple of subsections, but I'm going to walk around in a loop. I'm going to close that loop out, very similar to what I would do with a traverse. And then I would exit that room and then move on to the next room and create another loop. And the nice thing is, based with that loop closure, it helps out with any kind of error that the system may have while you're walking around. So there's a couple of different pieces of technology that are used with the SLAM algorithm. And I'll back up here. SLAM is an acronym, and it stands for Simultaneous Localization and Mapping. So we're actually using a couple of different components while you're out there mapping in an area. You're utilizing cameras, real cameras, similar to like what you would find on your cell phone. We're utilizing an IMU, again, very similar to what you would find on a cell phone, but very accurate IMU, very high-end digital camera, and then a LiDAR sensor. And in some cases, more than one LiDAR sensor. And those sensors are all working together to create that three-dimensional point cloud as you're walking around the job site and collecting that data and information. Now, the kicker is, as you're moving around, you are going to start to have some error build up, and we call that drift, right? So that's another key component that you have to keep an eye out for, is any kind of drift that you may have while you're working out on the job site. The nice thing is we're able to tie the system into traditional survey control, and we're going to dive into that here in a little bit. But I don't need to have any kind of special targets or no special paint or anything like that in the job site. I can use my traditional nail and disc. I can use an iron rod and cap that's got accurate survey control coordinates tied to it, and I could tie in my scan data into that in the field. So where SLAM works and where it doesn't work, this is always important. I've seen throughout my career people, think that the technology is good for everything, right? In the early days of scanning, that was one of the knee-jerk reactions. Oh, I can use a terrestrial scanner on everything, and I can use a SLAM scanner on everything, and that's not the case. You have to be careful, right? Some of the capabilities or areas that you can utilize it, if you've got your complex interior environments, those are great for SLAM technology. Again, you're the walking tripod. You're walking around inside the facility. You're able to move around any kind of obstructions and capture that data. Those large areas you can capture. If you have any kind of limited access, you're able to maneuver around that limitation. And completeness. So as I'm walking around, I'm basically a full 360-degree bubble of a laser scanner capturing that data in real time. Some of the limitations. So if you start to have a long linear corridor, an open area where there's limited geometry, I had a demonstration that I did recently in McDonough, Georgia. It was a very large area that had a retention pond. Although the scanner performed, it did great. I did share with the surveyor, I said, in a case like this, if I were in your shoes, I would have flown this with a LiDAR drone or a drone. SLAM scanning can do it. Absolutely. Can I get volumes? Absolutely. Can I, show the retention pond accurately? Yes. But at the same time, it may not be the right tool. Environments with repetitive featureless surfaces, we've had that before. Again, it can be done, but it's not the best use of the SLAM technology. And then any kind of a project that would require a legal defensibility without validation, i.e. doing some kind of a boundary survey. I'm not going to go and do boundaries with that. Sorry about that notification. Any questions so far? I don't see any hands. I'll just keep on going. Okay. So understanding accuracy when it comes to SLAM. So when people talk about SLAM accuracy, this is where things get a little confusing, unfortunately. Not all accuracy is the same, right? So you have your relative accuracy, and that's the internal consistency of the SLAM data. Then you have your absolute accuracy, and that's taking the SLAM registered data and tying it into the survey control like I was talking about a minute ago. You've got your drift accumulation over the distance that you're walking. And that's where loop closures will actually come into play and help you out. So as you're going around creating those loops, it'll help with any kind of a drift or any kind of a SLAM break that you may have, on top of then also tying into survey control. So a couple of different examples, you've got the bottom of the SLAM sensor. In this case, there is a device that you can go and place on the center of a target. You could also come over to the center of a rebar and cap and hit that control point. In our case, you need a minimum of 3 control points. I do recommend 4. That way, if Murphy's Law comes into play and one of them becomes an issue, you could always remove that from the least squares adjustment and then still have good, accurate data and tie that into survey control. Oop, lost my mouse here. Survey control still matters. So the SLAM does not replace control, right? Using this technology, we're not going out there and replacing, doing a control network. We're actually going to be changing the way we use it. We all use control for boundaries. We use it for doing construction staking, things like that. We're going to use ground control for good alignment. In some cases, we can go in and use wall control if we wanted to. So if I'm inside of a big warehouse, big building, I can do a combination of having control targets on the wall. I could have control on the ground and tie into all of them, no problem. And then that control will be used in the registration process when it does the least squares adjustment. Then I'll get a report when it's all said and done. This is a screenshot of an example of a report, surveyor's report from inside the software. It's going to show me all the different control points that I have, and then my residuals on my X, Y, and Z. In this case, it's showing them in millimeters. So, and the thing that I like is it does flag, you know, as we all know, Murphy's Law does exist in surveying. You know, sometimes a control point got run over, you know, I didn't know about it. I come out there and the elevation is off, or maybe the, you know, the Z and the Y are off. I can go in there, you know, even before I start the processing, it'll highlight that for me. I can uncheck that control point and then continue to process like nothing even happened. So what does this look like in the field? What is the workflow? Believe it or not, the workflow with SLAM technology is relatively easy. I like to say I could pretty much take anybody in about 5 minutes, even if they've never scanned before, teach them how to take the device, go out there, do good loop closures, and capture data. So the idea is you want to go out, you want to plan your path. And this doesn't need to be anything formal. You could just take a look at the site that you're working on and visually say, all right, this is how I'm going to create my loops. You're going to start your scan, you know, create your database, start your scan, tie into control as you're walking around, and the data set, you know, so you could, after an hour of scanning, stop, save that data, and then you'll upload that data to the cloud. Once the data is on the cloud, it'll go through the process of registering, and then it'll spit out your surveyor's report, and then you'll have your fully registered three-dimensional point cloud data that you could then export out as an E57 or an LAS or an RCS, whatever file format you like to use, so you can start creating your deliverable. And that's key, right? Go out there, capture the data as quickly and safely and easily as possible, convert that data into the point cloud, and then take that point cloud and pick up where you would normally leave off and start your deliverable creation process. So choosing the right tool for the job, again, you know, SLAM scanning, terrestrial scanning, total station, you know, they all have their own specific niches where they are very beneficial, very powerful. So for the conventional side of things, you know, I'm going to be using that on my boundary. I'm going to do my layout. I'm going to do my control networks, right? For terrestrial scanning, I'm going to go in there and I'm going to use it if I got to do anchor bolt locations, if I need to, you know, get the exterior of a building and go up high. A lot of the terrestrial scanners can go really far. And then SLAM scanning, you know, I can go do my interiors. I could do exteriors with it if I need to. I think that's one unfortunate misconception in the industry, that SLAM scanning is only good for inside, where SLAM scanning can be used both inside and outside. Would I go do 5 miles of roadway with a wearable SLAM scanner? Absolutely not. Could I do it? Sure. But, you know, in a case like that, there's other tools that I could use. I've got mobile mapping, you know, that I can mount on a vehicle and go drive those 5 miles and get good, accurate data. Where SLAM fits into the real world survey work, you know, we started to kind of touch on that. So it's best suited for environments that require speed, coverage, and mobility. A couple of just, you know, examples here, you know, using it in a topographic sense. The lower right-hand corner, that is down in North Miami, Florida. It's the top of a condominium. It was an active construction site. The site did not need to get shut down. The little blurring that you see here is, believe it or not, a construction worker that was within a couple of feet from me as I was walking around and scanning. This is a customer of ours in Western Florida. Right after one of the hurricanes hit a couple of years ago, they went out and deployed, and they were able to go and map this crane that had fallen down due to the hurricane's winds. So that was all documented very easily, very safely, and very quickly. So there's a large number of areas that you can go and utilize this technology where it'll be extremely beneficial. Now, where it's not the right tool, right? A little bit of a plot twist. I know there are people out there that'll tell you, oh, it could do everything, and it can't, right? You know, I'm not going to use it on a boundary survey. I'm not going to use it for any kind of legal work, you know, in terms of determinations. Like, you know, it's not a good idea. I can get the topography, but I'm not going to use it for that boundary. I'm not going to do any kind of, you know, high precision layout or staking. It's not a staking tool. I'm not going to use it to establish my control network. You know, we've got GNSS and we've got high accuracy, you know, robots that we can use, total stations that we can use. Open featureless environments, again, not really a great area. You know, I was talking about that large retention pond. Did it do it? Sure. Was it the best use? Not really. And then those long linear corridors, you know, without any kind of loop closures. You know, if I'm doing those long corridors, I better make sure I'm doing a really good job with my loop closures. And in those cases, we like to call it, or at least I like to call it, your loop closures are going to look like a chain link fence. You know, you've got your loops that are just overlapping as you're walking down that long corridor. So now I like to dive into some real world applications. You know, it's cool to talk about the technology, but then, you know, I'm sure everybody's sitting there going, well, how can I use it? How is it going to help me in my day-to-day life? Believe it or not, there are a lot of areas and applications where it's very beneficial. So I tried to pick a company not in Georgia so that, you know, nobody felt like there was a competitive issue. So the customer is ETM. They're out of Jacksonville, Florida. They're a civil engineering surveying firm, been in business a very long time, been a customer of NavVis for over 2 years now. They worked on an active site. This is a football stadium. We'll just leave it at that with no names. It was a very complicated and complex environment. They needed to go out there and map everything for the survey. And you'll see in the lower right-hand corner, that's the actual deliverable that was created in MicroStation based off of the point cloud data. I do want to point out, this is a very nice blending of technology. So this was a combination of SLAM technology, aerial LiDAR technology, and terrestrial LiDAR technology. So they were able to go out there and use all three to create the deliverable, the point cloud that you see there. And that point cloud was brought into an online service system where the owners of the football stadium could go in there and take measurements almost to their heart's desire. You know, so they could go in there and access the data anytime they want and get any kind of a measurement that they need, an elevation, a coordinate value. That is user definable in a lot of cases, right? So some surveyors may say, I don't want my customer in there playing with the data. No problem. You know, you can go in there and change those different permissions to prevent that. But the key thing that this customer said that always caught me was by utilizing the technology, the SLAM technology, they were able to save, you know, anywhere from 35 to 50% in the field versus just using a terrestrial scanner. Now, again, they did deploy the terrestrial scanner. They did have areas where the SLAM technology wasn't able to shoot far enough, and they did use it out there, but they were able to combine the two technologies together, which is pretty powerful. Very helpful, right? What are we always looking for at the end of the day? We're always looking for another tool to add to the toolbox to help us, you know, be as adaptive as possible. So from capture to usable data, that's the next big kind of thing that I have people ask, okay, Frank, we've got the data, now what do we do with it? And in this case, you know, you've got a couple of different pieces of data that are very powerful. I just kind of was talking about it here a minute ago, the online capability of viewing and sharing the data with the downstream customer. So they can go in there and take measurements, take, you know, elevations, they can go and take coordinate values. You've got your registered point cloud. Of course, that could be brought into any of the many different software packages that are out there today. You know, and I'm going to throw different names out there, not citing with any one particular vendor, but Trimble's got, you know, the ability with RealWorks and TBC to handle point cloud data. Carlson has their own point cloud engine. AutoCAD can now even take in point cloud data. You've got TopoDot, you've got MicroStation, Leica has their Cyclone products. So that, there's throw a rock and you've got 500 different software packages that can handle point cloud data today, which again is very, very useful, very powerful. It's a good thing to have. You could do QA QC validation. So I have the ability to pull in a model. Let's just say in this case, I had a 3D model that was generated. I can import that model in and then check against how the point cloud data overlays on top of it and start looking to see if everything matches up correctly. A lot of customers will use the point cloud and model for clash detection in the industrial side of things. A very good use. Is this object going to fit before I even bring it into the building? I could verify it'll fit or not. There's a customer that I have in the Panhandle, and they go and put in industrial-sized washing machines and dryers. If you think about, restaurants, they've got all kinds of linen. This company installs the equipment for that linen to get washed and cleaned. Well, as they bring in new, more modern washers and dryers, and again, I'm talking about massive, the size of massive rooms, they need to make sure that they can get it in the door. And once they have it into the building, will it fit or is it going to interfere with anything? And they've had several cases where there was an electrical panel or some piping or HVAC ductwork that would have interfered with bringing that equipment in. It would have shut down the entire site for a very long period of time. By having that point cloud in advance and having the model in advance, they were able to basically go out into the field, completely engineer what the fix, even before that equipment showed up, so that they didn't have any real downtime other than moving the equipment, which they had already planned for. Just saves, you could almost not even put a price on how much that would cost or in savings, right? I always like to include, what a typical deliverable can look like off of point cloud data. This is a truck stop down in Florida off of I-75. There is a colorized version. I didn't think it would show up as good as the black and white, but just your typical black and white drawing that you would plot out and then sign and seal and give to your end customer. So some common mistakes in SLAM workflows, there are, unfortunately, and most of them are not in the hardware. They're actually in the workflow and how they're actually out there using the technology. So that, they'll go out to a site, they won't have a defined control strategy. They will have a poor scan path. They won't do loop closures. They'll start jerking the equipment around. I had a situation where a surveyor was out and unfortunately, he thought the loop closure, he had to do a full circle, just a full 360-degree circle without moving. And you start moving the equipment around without it knowing where it is, you're going to start breaking that SLAM algorithm. You don't want to over rely on the manufacturer's specifications. It's always good to know what they are, right? And know the limits of what those are as well. You definitely don't want to skip your validation against the control. And please don't treat SLAM as a push button solution. As much as we would all love for the technology to be at that point, it's not. It's no different than taking GNSS data or having to reduce a survey traverse via least squares to make sure you get the best solution. So you gotta think. You don't get to stop thinking because it's SLAM. So when should you use SLAM technology? So these are some of the different questions you want to ask yourself before going out and deploying with it. Do I need full coverage? Do I need that digital twin of the entire site? Is speed or limited access something that I'm going to encounter while I'm out there? Does the environment support doing my loop closures? If I have a very dense treed area with vegetation and kudzu all over the place, and I need to do a topo of it, I'm going to have to either cut out that kudzu or cut a good walking path or just use my traditional survey methods. Now, having said that, I do have customers that will go out and do tree surveys. It's a more open area. It's free flowing. They're able to walk around very easily. So that is the benefit, and that is something just to keep in mind while you're utilizing the technology. What level of accuracy is being asked of me and required? And is this for measurement, documentation, or is it for both? So all those things you want to keep in mind while you're out there, getting ready to go and deploy with the SLAM technology. And if it fits the job, it's definitely extremely effective. It, to this day, still blows my socks off. I had down in also McDonough, I did a Chipotle in less than 9 minutes. The entire exterior of the Chipotle, fully scanned, just one person, myself, walking around. I would have done the Chick-fil-A, but the Chick-fil-A it was a very busy parking lot. This was lunchtime, so they didn't even have to shut down the parking lot. Just walked around, scanned, and was done. So final thoughts, some stuff just to leave with all of you. SLAM doesn't replace surveying, right? I think we all know that, but it does support it. It does support surveying when used correctly, right? If it fits the job, it can save time, it can improve that coverage, and it can absolutely reduce that risk. And if it doesn't, you've got better tools in your toolbox. Go and deploy with them. The value isn't in the technology, but the value is in how you actually go out there and apply it. So used correctly, it's powerful. Used incorrectly, it's point cloud noise. Any questions? This is why I like doing it in person, because I could see people's faces. Sarah, I guess I'll turn it over to you. Thank you all very much for your time. Really appreciate it. Hopefully you found it informative. Appreciate it. Oh yeah, Khalil, do you mind throwing that in there for them? Yep, there it is. So no obligation. If you're interested in throwing your information on there, thank you. If you're not, I understand. We promise we're not going to barrage you with 5,000 phone calls and 450 emails. But yeah, we'd be more than happy to talk to you. I do always recommend, when you're evaluating any kind of technology, but specifically SLAM technology, it's always good to do I like to call it an apples to apples comparison. So if you had something that you've already conventionally surveyed, or, say you utilize terrestrial scanning, bring the SLAM technology out there, have it tie into survey control, and have it create that point cloud, and do a comparison, do a real world comparison. I do highly recommend it. It's a lot of fun. Myself, I love going out and doing those types of jobs. I call them jobs, but it's a demo, right? But that data can really show you the value and the time savings of going out into the field and collecting the data. So thanks, Sarah. So yeah, believe it or not, and I can speak to NavVis specifically. NavVis has a partnership with Esri, where they can take in our point cloud data. So yeah, it can be done. I actually have a company that I'm working with in South Florida right now. 911 uses a lot of GIS information, and they are in the process of utilizing our technology to create maps for the 911 call takers, so that when, God forbid, somebody has to dial 911, and let's just say they're in a bedroom, and you have a map of that condominium, you could literally see the spot where they call from, because the 911 system will access the phone's GPS and plot it accurately on the map. So a lot of states are, just in this, for schools, elementary, middle, high school, college, universities are mandating that those schools are mapped out very accurately. And that is why. That's the reason behind it. So yeah, good question. Anybody else? All right. Thank you all. Again, I appreciate it. Thank you, Tyler.